This is Note Taking Guide 5.4 for Mathematical Decision Making for Life. So today, you guys, we've been talking about different kinds of probabilities. Today I'm going to show you something called a factorial so that we can do some things called permutations and combinations. So before we even get started, let's just talk about what a factorial is. So think about it for just a minute. If you wanted to arrange 8 of your favorite books, because I know you guys always want to do that. You're like, ooh, look at those 8 books over there. I need to rearrange those, okay? And you wanted to rearrange them. How many different ways could you do that? Well, how many choices would you have for the first spot in the bookcase? You'd have 8 choices because there was 8 books. But after you use one of the books, you only have 7 choices left, right? Then 6, then 5, then 4, then 3, then 2, then 1. When you do that, all 8 spots in the bookshelf are taken by all 8 books. This is called a factorial, when you take one number and you will multiply it all the way down till you get to 1. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is also called 8 factorial. Anybody know another name for that symbol right there? Yeah, in Mr. Murphy's class you would say an exclamation point, right? In math, that symbol is called a factorial. And what that symbol means is multiply from 8 all the way down to 1. So you could do that on your calculator. Everybody do that real fast. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Someone else got that to verify we did that correct? Yeah. Okay, so did you enjoy punching 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 in your calculator? Totally. Like if that was good therapy for you, you guys keep doing it, okay? If you'd rather have this key on your calculator, let me show you where to find it. Do you see this probability key right here? Hit that, well, I'm going to put the number 8 in, then hit that probability key. Anybody see that exclamation point? It's number 3, right? So you can either arrow down or you can hit number 3. It puts that exclamation point behind the 8 on your number, and then if you hit enter, it gives you that number. So that is called the factorial key. You find it underneath the probability menu right here, and you can use that so you don't have to punch in the numbers in your calculator. Do you like that key? That's a nice key, right? Okay, so really fast, let's find these factorials. So 3 factorial is 6. Now that one might have been easier to do in your head when you think about it. 3 times 2 times 1. I know, do it on your calculator. Okay, 8 factorial, we actually just did that, right? It's not going to change, so it's at 40,320. What about 0 factorial?
1.
Did you punch it in to know? 0 factorial is actually 1. That's just a rule you're going to have to memorize. Or punch it in your calculator every single time so you don't make a mistake. And then 5 factorial? 120. So everybody's going to want to make sure they have their calculator with them today while you're doing your homework, because those factorials are so much easier on the calculator. So hit the probability key. And then it's number 3 on that menu. Okay. All right, other questions on how to find that? All right, so the next question then says, how many ways can 5 paintings be lined up on a wall? Again, that would be 5 choices, 4 choices, 3, 2, and 1, which can be written as 5 factorial. We actually just did 5 factorial on the other problem, but so it's going to be that same value every single time. So you have 120 ways that you could arrange those paintings up on a wall. Does that almost seem overwhelming when you think about it? Like, gosh, when you put 5 things in your backpack or whatever, do you think about having 120 ways you could put those in your backpack? No, like you just put them in your backpack, right? Sometimes when we start thinking about it, it gets a little more overwhelming. Interesting, again, to think about this, though, compared to yesterday when we were talking about PIN numbers on your debit card and stuff, right? Some of these things are pretty high considering the fact that what we're looking at. All right, next example says, imagine that you have 7 songs randomly playing on your MP3 player, which you guys probably don't even know what that is anymore, from all the same album. What is the probability that the 7 songs played will play in the same order they appeared on the album? So again, in order for that to happen, you would have to do 7 times 6 times 5 times 4 times 3 times 2 times 1 for them to get in that order. Anybody do 7 factorial on their calculator? I need a 0 in there, huh? Yeah. Sorry. Okay, let me start over. 5,040, like that, right? So it actually says what's the probability that that will happen? Well, you have 540 different ways that that could happen. So the probability that that would happen the way it's supposed to would be 1 out of 5,040, right? Because only one time would those songs be in the exact same order that they are on the album. Does that make sense how we figured out that probability? So the probability is right here. Okay, questions on that? Right here. No, you're fine. Okay, next one. My fruit salad is a combination of apples, grapes, and bananas. We don't care about what order our fruits are in. They could also be bananas, grapes, and apples. Do you guys agree with me that when you make a fruit salad, no matter if I put my fruit in that order, the bananas, grapes, and apples, or apples, grapes, and bananas, it would be the same fruit salad? Everybody agrees with me on that? Okay. But what about this? What about if the combination to my safe is 472? Now do we care about what order those numbers are in? Because 742 won't work even though I use the same numbers. And 247 won't work even though it's the same 3 numbers. It has to be exactly 472. So in math, I skipped a problem, didn't I? Sorry. So in math, we are more precise with our language. So we're going to talk about the difference between when order matters and when order doesn't matter. So order matters, order doesn't matter in math. Sometimes we call it a combination, and that's when order does not matter. Sometimes we call it a permutation. That's when order does matter. So I like to remember it this way. So if you ask for a combination pizza, does it matter if they put the pepperoni, sausage, and peppers, or the peppers, pepperoni, sausage? Does it matter which order they put it in, put the toppings on your pizza? No. It doesn't matter, right? It's the same pizza no matter what. So when you think about a combination, think about a pizza. So order does not matter. Order does matter. We're going to do something called a permutation. And we're going to come back to that in just a minute because I accidentally skipped a problem. So let's go back and do this one right here. Again, you guys, I'm going to do this by hand just so you know how it works, but you can punch this on your calculator while you're waiting for me. This would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then this would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Do you see that the 1s will cancel, the 2s will cancel, the 3s will cancel, the 4s will cancel, the 5s will cancel, the 6s will cancel, and the 7s will cancel. So really on the top, all I have is 8 times 9 times 10. But again, you can punch this on your calculator, and what did it give you for the answer? 720. But I wanted to show you how that works. So it works like that. You can punch it in your calculator. Okay, so one more review really quick. Sometimes when we're doing stuff, order matters. When order matters, it's called a permutation. Sometimes when we're doing stuff, order doesn't matter. When the order doesn't matter, it's called a combination. Okay, so let's read these and see what's happening here. If I have 3 people running a race, and I need to know how many ways they can place, if I give out a first, second, and third place medal, then this is a factorial, because I'd have 3 times 2 times 1, because there was 3 people running the race. 3 would have a chance at first place, then 2 would have a chance at second place, and 1 would have a chance at third place. So 3 times 2 times 1. Okay? If we run the race again, but this time there are 7 people running the race, but we still only have 3 medals. This is not a permutation, but this is not a permutation. Let's see why. How many choices are there for first place? There's 7 people. I think that's supposed to say factorial. How many choices are there for second place? And how many places for third? Yeah. So do you see how we didn't go all the way down to 1? So 7 times 6 times 5 is not a factorial. It's actually going to be called a permutation because we didn't use all of the numbers. So what's 7 times 6 times 5? I think it's 210. Does anybody else get 210? So there's actually 210 ways if there were 7 people running the race. So the way I like to remember if I'm using a factorial or not, factorials work when you use all of the things. So 3 people running the race, 3 people get a medal. 8 books on the shelf, 8 of them are being arranged. This time there were 7 people running the race and we were only going to give 3 of them medals. So we only used part of what was happening there. So how can you tell the difference between what a permutation and a combination is? Permutations are like arranging people, digits, numbers, alphabets, letters, and colors. Keywords are arrangement or arrange. Combination is like selection of a menu or food, clothes, subjects, teams, and keywords are like select and choice. So let me kind of show you what we're talking about here as we do this, okay? So a couple examples on the back. Here's your formulas for permutations and combinations. You guys, you really don't care what the formulas are because, again, on that probability key, let me turn my calculator on. You see how it says the P is the permutations and your C is your combinations. So if I need you to find the permutations of something, we're going to put our number in, hit this key, put our number in. If I need you to find the combination, you're going to put a number in, hit this key, put a number in. So let me tell you what I'm talking about here, okay? So it says, in a class of 10 students, I need a president, vice president, and secretary. So did you notice how order mattered? President matters, vice president matters, secretary matters, okay? Because that matters, that would be a permutation. So I'm taking 10 people and I'm going to choose them 3 at a time. Because didn't I have a president, a vice president, and a secretary? So 3 times, right? So punch this on your calculator to see how many ways that can happen. So put the number 10 in your calculator. Hit that probability key. And then hit number 1. And then put the number 3 in. And it will tell you that you have 720 different ways for that to happen. Okay. Anybody else need help with their calculator? So the difference between that and a combination, so the same kind of example here. It says in class 10 students, there's 10 students. I need a group of 3. Does a group of 3 kids matter what order you pick them in? No, a group of 3 doesn't matter what order you pick them in. So that means this time I'm going to do a combination of 3 people out of the group of 10. And when you do that on your calculator, what do you get? 120. So combinations are almost always the smaller group of numbers because you're kind of eliminating different chances of that happening because the order doesn't matter. So in this case where president, vice president, and secretary mattered, the same 3 kids, if you put one of them as president, it would be different than having one of them as vice president. Where here, if you're just picking 3 of them to be like in student government, it doesn't matter what position they're in. So let's do some of these examples and see if you can figure out if they're permutations or combinations. So in how many ways can you arrange 3 of 4 letters in the word math? So it said the word arrange. Does anybody remember on my little cheat sheet over here that it said arrange falls under permutations, right? So we're going to do a permutation in this case. We're going to do 4 letters taken 3 at a time. So you just have to punch that in your calculator. And your answer is 4. Thank you. Oh, 24 you said. So 24 different ways you can take 3 of the letters and arrange them. Okay. Questions on that? All right. In how many ways can you select 3 of 4 letters in the word math? So select, when you look at it over here, that's going to be a combination. So same math with combination this time. So 4 items taken 3 at a time. This time I got the number 4. Is that what you guys got? When you punch it in your calculator? Okay, next one. How many ways can you select a first, second, and third place finisher from a race of 10 runners? Okay. So does first, second, and third place, does that matter the order?
Yes.
Yeah, I mean, I would be upset if they gave me the second place medal when I earned first place. Wouldn't you guys be upset? Yeah, so order does matter here. So which one is the one where order matters? Is permutation, right? So we're taking 10 runners and 3 at a time because the 3 places matter to us. So 10 runners taken 3 at a time. You're going to punch that in your calculator as a permutation. When you do that, you get 720. So there's 720 ways you could have a first, second, and third place out of those 10 runners. That kind of seems crazy, doesn't it? But that's the way it will work. Then the next question. Oh, yep. Okay, the next question says, how many ways can you select a committee of 3 out of 12 students? So again, committee is more like that combination pizza. It doesn't matter which order they're selected in. So we're going to do combination. We'll do 12 combination, 3 at a time, because we're taking 3 students out of the 12. And we're just going to punch that in our calculator as a combination. I got 220. Did you guys get 220? Yeah. So there's only 220 ways to grab 3 people out of a group of 12. Okay. This next part is all just practice. Punching in your calculator. So do a permutation of 4 items taken 2 at a time. What did you say? 12. Thank you. A permutation of 10 items taken 4 at a time. Combination of 8 items taken 2 at a time. 28, is that what you said?
Yeah.
Thank you. I have an hard time hearing. And then a combination of 12 items taken 6 at a time. 924. Okay, questions on how we did that today? So again, just to reiterate one more time, you use permutations when the order matters, and you use combinations when the order does not matter. Those keys are on your calculator, so use them. It makes it really easy.